Okay, right, so this is integration by substitution. So in your notes, can you write integration by substitution? So pause me if you spotted anything, or if you have any questions. Okay, so how do we integrate? So so let's do an example one. So if we integrate y equal to, sorry, get rid of the integrate, y equal to integral of 2x plus 3 to the power of 4 dx. Now, hopefully you will agree that you've seen this before in the differentiation. If you remember, with the differentiation, we're going to let that to be u, and then we differentiate. It's the same idea. Okay, so one more time then, we are going to let this be u. Okay, so if you like, we can do the 4 boxes. Okay, so so mainly if I make, so we're going to let this equal to u. Okay, so when do we use integration by substitution? When you see an algebra type with a bracket and a power at on the outside, that's when you choose. Don't try to use integration by parts. When do you use integration by parts? What's the properties of the questions looks like? Only one word, they multiply. The terms are multiplying. In this case, it's not a product, it's adding, plus is a power of. So that's when you really use integration by substitution. If you're doing A level, what happens is this bit here, you have to do integration by parts, and then you have to do integration by substitution all in the same question. Okay, but yeah, well, you would do the integration by substitution first, like we're doing now. Then, how do you integrate the u? And it happens, if this is times, then you would have to use that. Okay, so it's a 15 marks question in A level. Okay, yeah, there's only 6 questions in A level, and you have to do it in 2 hours, and they are half an hour long, some of them. Yeah, if I had changed that to be multiplying, so if I put that bit in here, that would take you about half an hour for sort of novice. Okay, so anyway, this is not, so in this case we can just do this. So so therefore what we have here is y equal to integrating a u dx, isn't it? U to the power 4. Yeah, sorry, thank you. So I will need, so that's that one. Okay, what's the problem? What's the problem? Why can't I integrate u to the power 4? I mentioned this in the previous session. The focus is on here. Why can't I integrate u4? So if I integrate u4, you probably will think it should be u5 over 5. Yeah. Well, why can't I integrate? What's wrong with this? It's a syntax. What is it? What's stopping me? What's stopping me in this question from integrating the u to the power 4? No, not at all. That is 1. Because if I give you this, you probably give me the answer u to the power 5 over 5. But you can't, because I said it several times before, is that it is, come on, one more time. It's here. It's not the maths. It's because the integration is in respect of x. What letter is this? U. So this must be a du in order for you to integrate. Do you understand? So therefore, Your second question you should be asking yourself is, how do I change the dx to become du? Okay, so the book doesn't tell you this, and this is something that that the book think it should be obvious, but it is not obvious. Okay, so I'm going to make a note. So if you also make a note as well, you can't integrate in respect of x. It must be in respect of u. Okay, so well, this is where the box becomes useful. So if I just set up different color here, so I might not need to use the 4 sections. So I'm going to put u equal to 2x plus 3 here. Okay, and I'm going to du by dx. Because why do I do dx? Is because the algebra involves letter x, so it's du by dx, right? Right, quickly then, what's differentiate the u equal to? What's du by dx equal to? If you differentiate 2x plus 3, it will be... Come on. I'm waiting. Now, especially if I given you a distinction on your first assignment, and then you are sitting here thinking, what is differentiate 2x by plus 3 equal to? What's differentiate 2x plus 3? Thank you. Yes, it's 2. Yeah, well, you said more than that. Look, honestly. Yeah, exactly, that's what you said. That's what you said. Yes. Well, you've been calling out a lot of answers. I'm just waiting for you to change it. Is that so? That's your final answer. So it is 2. Okay. So it's 2. Yep. That's it, isn't it? Yeah. That's so du by dx. This is differentiation. Differentiation. Yeah. Differentiation. Okay. So this is it. Look here and look here. What can I write dx to become? So let me write this out here. So if du over dx is equal to 2, what's dx equal to? Yes, it's du over 2. Yeah. Yeah, this is where the questions come in. Yeah. Is it 2 over du or du over 2? Well, if you throw the numerator onto the other side, it still may remain as a numerator. Okay, so we have it. We have a dx now can be converted into the letter u. So now I can put this in here. So now I can substitute into here. So if you get more space in your notes, so you can notate however you like. So this is how I do it with this much space. So substitute into there, and that's why it's called integration by substitution. Okay, so this is where it's happening. Okay, so if I rub this off, then we can use this space here to demonstrate further. So therefore now y is equal to integrate u4, u to the power 4, du over 2. Well, any constant, so if I make a note again, any constant can be brought out of the integral. So, before you take any notes, this is what I mean. This is a constant. It's divided by 2, right? Which is a half. So you can now bring the half out of the integral to rewrite this. So yes, y equal to half integrate u4 du. Now can we integrate? Yes, we can. Because we can now integrate u in respect of u. Yeah, that's how this is where it's happening now. Okay, so let me go to the next slide. So y equal to half integrate u for du. Now remember, we're not differentiating, we're integrating, so you have to add 1 to the indices first. So y is equal to half u4 plus 1, which is 5, and that becomes a fractions of becomes a fifth for in front of your u, which is over 5, and then plus c. Are we all happy with this integration? Do you understand? So it's going back to basic. I'm trying to find you the formula. So basically, the general rule for the integration, if you have forgotten, is this. So if you integrate x n, okay, that is equivalent to x n plus 1 over n plus 1. That's what it is. Okay, n plus 1 over n plus 1. Yep. Okay. So let's move on. So I'm doing it slowly than usual. Slower than usual. So so that becomes well, 5 times 2, because fractions times to make 1 over 10, and then u to the power 5 plus c, isn't it? Well, what's u? What's u? What was u? What did we say u was? Yeah, we finish. So recall. So again, using red here, recall that u is equal to 2x plus 3, right? So now we can put that back in, and that's your final answer. So you can write 2x plus 3. This time is power of 5 over 10. Instead of writing 1/10 of, why not just do divide by 10 plus c? Finish. Any question? So I'm pausing and explaining, but it is quite straightforward. So as long as there's evidence of a substitution happening, okay? So if I just give you a moment to write this down, and I just summarize from the beginning. So this is the bit you need to remember. So remember to substitute. So don't write your answer at the end to have a u in it. Okay, u isn't the actual question. The actual question has letter x, the variable x. Okay, so let me summarize what happened. Everything begins by you observing that there is a possibility of solving this using a substitution method. The first thing you need to do is to let whatever is in the bracket to become a u. And you can't integrate because it's in respect of x, so therefore you need to differentiate your u to get an equation where you can rearrange such that you can have dx as a subject, so that in this case is du over 2. You put that in there, so now you got that. Take that constant to the front of the integral, and you're left with an integral that you can integrate quite simply. And then using the old traditional integration method, then you get this, and then make sure you substitute your u back into it in respect of x, and that's it. Okay, so